data which we find at the crime scenes, right? So any crime scenes, it doesn't mean it is only a murder. It can be a theft, right? If somebody is stealing someone houses uh, house things, and it is also a kind of uh, theft. And forensics is a kind of uh, way of finding the, you can say it as a evidence, right? So how it has been happened and who were involved in this particular crimes and all. So that is basically forensics do, right? So forensics is actually a department, right, who takes the data in the form of pictures, in the form of fingerprints and all at the different crime scenes. It could be a murder, it could be a theft, it could be a, anything else, right? Which is in a judicial system. It's a basically a kind of crime, right? Which counts as a crime. So jurisdiction is having that kind of protocols that if something happens or something mishappens at some places, so any forensic teams will go there and collect out the data from there, what could happen and what kind of pictures are there, because if something mishappens, so there is nothing left. If somebody has done something, so it'll be always clear that we don't have to. We always have to clear the evidences so that will not be caught, right? So every time they'll have something, but that can be understood by only forensic teams because of they have microscopic things. They can analyze that microscopic things. They can apply some kind of patterns, right? So what people are coming, they have cameras installed there. If somebody somewhere any mishappening over there, so they'll find first of all, is there any camera installed or not? Say they found footages from there, right? And then take out some kind of pictures from there, right, where this happens. Actually they take out the fingerprints and all. They find any suspicious thing from there. So there are lots of data which could be found from the crime scenes, right? So we have already seen these things from the movies. We have already watched some movie, let's say, and there are some kind of things happening, right? So we can understood that yeah, this is the way they are working, right? And they have all the permissions. If somebody is from the forensic teams, the jurisdictions always allow them that you will go there and you will find the data from there, and if something you will find, you can give that data to the police and all who are investigating them. So this is basically a forensics do. And what is the role of forensics in IoT that we are going to study today, right? And this session start from cybercrime. First of all, it it could be of any crime. There is existing cybercrime also, because if the internet data is theft is there, it's a cyber crime, right? If somebody has stolen your data from your account, if somebody has stolen some money from your bank account, so it's also come into the crime, right? If somebody has also stolen something from your house, it's also crime. Somebody murders, somebody has EFTs, somebody something, anything could be happen in the sense of crime, right? But how do we track them? If something mishappens, how do we track them? That is the important thing, right? Because it's happened only, right? But if we need to find out how it happens and who were involved in that crimes, we need to take some helps from technologies also, right? We have also technologies to find out those all evidences from different ways. So first of all, cybercrime. We are studying about cybercrime, which is a serious threat to any organization. So that is also a very big crime to stealing the data from any companies, from any bank systems. With data breach cost reaching over $4 million on average, companies today face many potential cyber risks each year, and the results can be catastrophic. Right? It may be changed, but obviously it is basically companies are facing this kind of thing. If I have data and data breach is nothing, it's not a big issues in this time. Obviously it's a big issues, but for them who is hacking, who is doing this crime, for them it is a very easy task to stealing the data, because they have lots of ways to steal it, right? So since Internet of Things, devices often face attacks as soon as 5 minutes after connecting. They can present as a server's vulnerability. The number of devices connected to the internet has skyrocketed and now includes many medical devices, smartphones, components, and even e-cigarettes. So Internet of Things devices can track them in under the 5 minutes only. Within the 5 minutes, they can be easily tracked or something. The pursuit of cybercrime in IoT environment often requires complex investigations, where the traditional digital forensics methodology may struggle to support the forensics investigators. So sometimes the traditional way of using forensics, digital, maybe it's digital forensics, but sometimes they struggles to find out the evidences, right? And because some of them were that much complex, they'll not decrypt it, they'll not able to find the actual solutions, right? They'll not find the actual culprits from there. So we we try to make some kind of system which is based on IoT, so that it can be digitally enhanced system, right? And it can find that same evidences in a decrypt manner, even if it is complex, right? So this is due to the nature of technologies such as RFID, sensors, and cloud computing. So we generally use RFID. Obviously, in IoT, we in a major way we use RFID, radio frequency identifications, to uh, identify any objects, identify anything. Like sensors are also RFIDs, right? Sometimes. And sensors and cloud computing used to IoT environment together with the large and huge amount of heterogeneous information and borderless cyber infrastructures, rising new challenges in the modern digital forensics. So basically, we use this kind of things. If somebody has a kind of a structure at their home which is based on IoT, they have all the informations there, from their laptops, from their phones, from their refrigerator, from their ACs, from their cameras, right? If it is installed with the IoT, so lots of things are there to collecting the data. But sometimes it is collecting the data in the manner that it cannot be decrypted to anybody else, right? The person who is on, if it is a private network, and if it is they are using a private kind of accounts, so if that is private, that cannot be taken after something mishappens, right? If something mishappens, so whatever the data is collected at the cloud or at the network, that cannot be decrypted. That is actually the problem. Sometimes it's a very complex data to decrypt. So that is how we face challenges when we used to try solve this kind of forensics way. So start from, in the last few years, many researchers have been conducted discussing the challenges facing digital forensic investigators and impact of these challenges bring upon the field. Some of these challenges include the ambiguity of data location, right? Data acquisitions, diversity of devices, various data types, vol- volatile of data, and the lack of adequate forensic tools, right? So these are the challenges we are facing when we used to work with the forensics in IoT, right? And moreover, while there are many technical challenges in IoT forensics, there are also non-technical challenges are there. So some as determining what are IoT devices, how to forensically acquire data, and secure the chain of custody among other unexplored areas, including resources required for training or type of applied forensic tools. So we'll be studying about that. And this study presents a second overview of IoT forensics challenges, focusing on a typical smart home investigation, right? Like we have a smart home and what kind of things we can have in a smart home, and we have some kind of frameworks also which is already made. We'll be discussing about it, and what are the differences, what are the comparison of that framework which is made with in the IoT forensics to conduct forensic investigation in the IoT environment. With the increase in IoT devices, basically cyber attacks happens because of there are we have lots of IoT devices connected, and we are it is increasing basically, right? So if let's say we have a city, in city 50% societies, 50% homes are smart homes, right? So from 50% smart homes, there will be lots of data is collected at a cloud or in fog computing or at cloud computing, right? So there are lots of data is being generated each and every day, right? So as the number of IoT devices are increased, the IoT related cyber attacks and have grown and giving rise to the field of IoT forensics, right? So the area of IoT forensics has also grown because of IoT devices has been increased and cyber attacks is also increased, right? What does digital forensics mean in the IoT context and what is its purpose? So first of all, IoT in forensics. The IoT refers to the connecting any device to the internet. That we have already discussed that if we talk about any IoT systems, so it is a device where we are collecting data and which is connected to internet. This is due to incredible capabilities this technology has provided. The Internet of Things is defined as the interconnection of uniquely identifiable embedded computing device within the existing internet infrastructure. Right? In simple, it involves things or objects such as sensor, actuators, RFID tags, and readers to interact and coordinate with each other, thereby reducing human intervention in basic everyday tasks. Conversely, the number of human interaction with these IoT systems creates a new paradigm for evidences-based data. With the current advancement in networks and communication system, IoT enables billion of growth and connectivity. Obviously, we have already done it. We have already studied about it, that how IoT impacts our life, right? In a daily basis also, in a different areas also, in the industries also, as we have seen that it works with IoT of everything. So our lives are im- impacting by these technologies, right? So if life is impacting and if there is any crime happens, that can be a very, a huge loss will be there if something mishappens with our data or with our systems, right? So tech analyst company IDC predicts, we have already introduced some security systems also that we have taken a look obviously in the previous session, how do we find out the securities into it. But somehow, if that much security we do have, there is also some kind of, breaches are also there. Obviously there will be breaches, and how do we find out that where this breach actually happened and how it is happened, so that we could be that we can find out from the forensics. And tech analyst company IDC predict that total there will be 41.6 billion connected IoT devices by 2025. It's obviously more than that, right? So different companies make some analysis on this. So some of the companies' data figure has different. Some companies has different data figures. So don't worry about this. So every company, I'm just writing over here because of different companies have given their analysis, given their data, right? So nearby around that kind of connected devices will be there, and if there are lots of connected device will be there, there'll be some virtual environment we have already created, and it has been increasing day by day, right? While IoT has increased productivity for the businesses, it has also introduced new risks and threats, such as security and privacy issues. Already we have discussed IoT device contains sensitivity and valuable data, and it has become one of the main source of attacks and cybercrime. The complexity of IoT in terms of integration of different communication technologies, devices, protocols, and standards make it difficult to ensure public and private security. Right. So that we have already discussed that whenever we comes to the security, every devices, every applications, every protocols, every standards, what we are working in IoT have different working areas and protocols. So that could be difficult for us to find out something if we have to find any particular data from there. So because of different protocols, it will be very difficult to find out, right? So that is actually the challenge of being a different so versatile things over there. Protecting data of IoT device has been challenging because of heterogeneous and dynamic feature of IoT. Even if precautions are carefully taken to the secure data, the level intelligence exhibited by cyber attackers is undoubtedly great. Attacks can be crafted not just from the public networks, but from the private sources also, such as cars, smartphones, and even smart homes also. So as a result, cyber attacks can have significant socio-economic impact on both global businesses and individuals, right? Beside that, digital forensic investigation is one of the important areas, right? We have already we are already working with the digital forensics, right? Investigations were one of the important areas that requires additional work, right? Despite the numerous benefits provided by IoT in various applications, the modern infrastructure are becoming so complex and virtualized, whereby digital forensic investigators are required to acquire and analyze evidences coming in many forms and different scenarios, right? Unlike computer-based investigation, where there exists the ACPO, Association of Chief Police Officers, guideline in order to make sure that correct procedure has been employed. Right. For the IoT environment, such as smart homes, there is not a formal integrated guide to obtain legal and analyze the evidences. Right. If let's say somebody has made their house or home at in the smart way, so they have implanted some kind of sensors and all, RFIDs and all. So you should have a legal permissions to read their data, right? So that it will be investigated, right? So there is actually not a formal rule or a formal, some kind of protocols that yes, this is a kind of smart home. Likewise, we do not have any kind of agreement from anywhere, right? If we something do, like we have given some amount or money amount to any bank, so we have a legal agreement with them, right? But any smart home, when we are applying, when we are installing some kind of smart homes in our home, so there is no any legal agreement for that. So what kind of, because we are using that for our privacy, for our security, right? So we have a legal agreement with our partners, but we don't have a legal agreement with the for any committee which are in the in a public services, right? So like Association of Chief Police Officer, Association of Policing is not actually have some kind of policy of making this kind of things, right? And they do not take the legal actions, right? If and they do not have any legal agreement with it. So recently, there has been a research conducted discussing the challenges facing digital forensic investigators, the impact of these challenges bring upon the field, right? Like if somebody has done it for their privacy, for their security, how can they give your data, right, to any other public committees who want to use it for investigations? So if they are using it as for the investigation, they will be public, right? And the data will be, breached out. So it cannot be done. Means this is basically the challenges we can face when we are applying this kind of thing. And here is the data ambiguity, data acquisition, diversity of devices is also a problem. The acquisition of access the data for investigation purpose become difficult for IoT forensic investigator due to constraint of services level agreements and volatile of the data, right? In IoT forensics, there are also non-technical challenges such as determining what are IoT devices, right? How forensically acquire data and secure the chain of custody among their unexplored area, including resources required for training or type of applied forensic tools, right? This is also some challenges out there. So what are the IoT forensics? So IoT forensics is the practice of analyzing IoT devices to investigate crime. So it's a analyzing of IoT devices, which is installed there, right? If somehow at some places where IoT devices are connected and some crime happens there, so how do we analyze that? How it happens? So that could be analyzed or investigate by IoT device itself because they have data, right? Organization or law enforcement may hire experts to gather and preserve data when investigating whether hackers used internet connected device to commit cyber crimes or examine the sources of security breaches, right? In some instances, breach out occurs due to malicious intent, right? It could be a viruses which is been sent from any softwares. In other cases, they may result for human error. For example, if any employee shares sensitive information due to phishing attack. What is phishing attack? Phishing attack is nothing. It's a kind of a software based theft, right? It's a kind of attack. It's a kind of a theft where data is being theft from the computers. Is, let's say some employees working in a company and they have some sensitive data in their systems. So some software, let's say some employees has accessed a software which was basically malicious, right? And there is some viruses into there. That virus attacked that system for finding out the data, for stealing the data from that computer or laptop, right? Or any system where it is kept. So that can be done, and that is actually called phishing attack. The employee may have no intentions to steal the data, right, and harm the company, yet the result of sharing that data accidentally can be just as a catastrophic, right? So this is basically a problem which can be done by intentionally or non-intentionally, but data is already lost and it can lead to a great impact and a huge impact and a huge losses also, right? In the financial way, in the professional ways also, right? So cyber forensics can help to determine the exact intent, intent and extent of a breach and much more. Typically, IoT related cyber threats may include malware, including ransomware also, right? Botnets and distributed denial post services attacks. It's a botnet. It's a kind of another systems is remotely hacking it, right? So that is called botnet, right? Bot means a predefined command is been already set with that machines, and that is hacking another system, another stealing another data from the another computers, which is in the network. That is called botnets. And any distributed denial of service means any distributed services where lots of computers are connected in a group, but any of the computers in a group has some kind of malicious uh, viruses. So that is also a problem with a group, right? Because there is nothing as it's a uh, individual computer is doing it. Okay. And next is data theft. IoT forensic does not involve the investigation of cyber crimes. Even on sites, crimes like burglaries may produce data on various devices that can assist in an investigation. However, the investigation process will vary depending on whether the device is smart or not, right? Because we can finding out the data from the smart devices only. So IoT forensics versus digital forensics. So what is the differences in between IoT forensics that we used to work with the IoT devices and digital forensics that we used to finding out from the digital scenarios or from the digital devices, right? Because IoT devices are different, it's a real-time devices, and only digital devices could be different, right? So in short, digital forensics in any forensic investigation dealing with the digital evidences, while IoT forensics is more specified branch of digital forensics focused on devices connected to the internet, right? So that is only the difference. Like if you are using the digital evidences, if you want to find any digital evidence, you should have any digital device with you. It is connected with any uh, internet or not, it doesn't matter, right? But in IoT, it matters whether your data is connected with any internet. Your IoT components or IoT devices are connected with the internet or not, right? So connection with the internet provides unfortunate opportunities for data corruptions or misplacements also, right? But it also ensured that most data is readily available for legal review for by an expert. IoT forensic expert use various methods to find digital evidences. So first of all, if we are into digital forensics, what kind of steps we follow to find to uh, follow these investigations? So first of all, identification is there. Whatever we are investigating, we just need to identify that. Second, we need to collect that identification. Yes, this is the information we need to collect. So first we identify the information and then we need to collect them. Third, we need to preserve them. Fourth, we need to examine them. Fifth, we have to analyze them and then we have to present them. Right. So these are basically the steps we need to follow when we used to work with digital forensics. Right. But in the IoT forensics, we have different levels. Device level, where we are collecting our data, right? IoT data will be collected by these homes, right? Any of the devices, any cameras, any scanners, any smartwatches, right? Any of the tabs or mobile phones and all. So these are the device levels from we collect the data. We can collect data from the network level also, right? From routers, right? From our CPUs, from our systems, right? From different ways, from hubs, right? And then we can have a cloud level also where we can collect the data. So we have different ways of collecting data, right? Because IoT has all the connections from device level to cloud level, right? So data has been generated somewhere else. It has been gone through with the different else networking system, and uh, uh, it is gone. It has been gone to the destinations, which is on the cloud level. So there are different ways to finding out the data from different levels, right? Now we are just into practice with the smart home scenarios, right? We just study. we are studying about these same thing, the IoT forensics with the help of smart homes. Right. So just discuss about smart homes, how smart homes work, and how smart homes has this IoT processes going on. So first of all, smart homes. One of the most widely used application of IoT is smart homes. Right? In a smart home, all devices like lights, locks, refrigerators, coffee makers, heating, cooling systems, and cameras are connected and controlled by central device through Wi-Fi. Right. Sometimes it is connected to Wi-Fi. Sometimes it is connected to Bluetooth. Sometimes it is connected to X10. It's also a device. UPB, Instanion, Z-Wave, and Zigbee. These all are the connecting devices, right, where data could be transferred from one way to another systems. So it enables people to control and monitor objects remotely from their smartphones and to accomplish personal tasks more easily and faster, right? It also offers many benefits to the homeowner, including energy savings, money savings, increasing security, right? So these are the benefits when a homeowner used to work with IoT systems. They apply IoT system at their home, right? So they can have energy savings also, right? And they can have money savings also. They can have increasing securities also. For example, smart lighting system is an integral part of a smart home and is a great way of controlling the ambience of home. Okay? So they can be easily controlled through simple voice command or mobile apps. So if you have any smart, lights at your home, so you can easily understand that how it is very. You don't have to go to the switches, to the physical switches to on it off, on it or off it, right? You only have some devices that you have handy phones, you have handy smartwatches, so that is always handy to you. So that from there you can also put some command to switch on that light, switch off that light, or changes the color for that light and all. So these voice commanded could be generated, right? And from mobile apps, you can easily take a single button and you can apply the actions on that smart home or any appliances, not only bulbs. It can be applied on any systems or any appliances in your home. So they can be programmed to turn on and turn off with user enter or leave the home, so user do not need to worry about wasting energy, right? Nest thermostat is a Wi-Fi based thermostat that allows user to control the heating and air conditioning system with an app or voice command. Right. So somebody has installed some ACs at their home and they want automatic heating control system. Right. Means if the AC has a temperature been set and it is already cool in, right. So already room is cool. So if automatically I want to generate a kind of thing that the AC will be automatically switched off because it's already cools the room. So what we'll do, we'll find out, we'll install a kind of a system which is Wi-Fi based thermostat, which will first check the temperature of a room and then convert it and then switched off the light and it will send to the command to the AC that it has to be switched off. Right. And it learns automatically from the user behavior and adjusts itself accordingly. Nest thermostat saves homeowners about 10 to 12% of heating and 15% of cooling. This translates to a savings of about 140 years per $140,000. I think it's $1 million per year. Maximizing home security is another amazing benefits of smart home devices. Right. By installing smart cameras, users can monitor their home anywhere, anytime, and receive security alerts on their mobile phone. So smart door locks and also reduce the risk of being locked out from the home. Right. The users can secure and lock the doors from anywhere with the internet access. Smart home devices are divided into smart appliances, securities, control, connectivity, home entertainment, energy management, and comfort and lighting also. Many companies and vendors are invested in smart home devices, and home market is expected to $141 billion by 2025. Right, this is a large amount, a financial amount, which is in the market, right? And they're investing it for making the house, making the home smart, right? So smart devices, we actually do it. We have lots of applications which are doing this, like we use Alexa, we use Amazon Echo Dot is a product name, is Echo Dot, that used to do the same thing. Google Home is also using the same thing. Apple Home is also doing the same thing. These all are the automated kind of system which is making your home a smart home, which is converting your home in a smart home, because they are actually controlling all of the house appliances by only a single device. Right? So many companies develop smart hubs and smartphones apps to control their own device. Wait a second. Different hubs support different connectivity protocols, such as Wi-Fi has a different protocol, Bluetooth has a different protocol, X10 has a different protocol, UPB, Insteon, Z-Waves, and Zigbee. X10 is an automation protocol which was developed in 1975 for home automation only. Right? It used home existing electrical wiring to send to the signal. And although X10 devices are outdated, but X10 protocol provides the foundation for wired technologies such as universal power line bus. Right. So X10 technologies has been already fleshed out from the in our networking areas, but now the protocol is still working. Right. Insteon uses both wired power lines and wireless technologies to communicate with other devices. When a problem occurs, it switches from one communication channel to the another, thus enhancing both speed and reliability over older technologies. Right. Insteon devices wirelessly connect to every other devices, creating a mesh network. In a mesh network, each devices communicate with each other directly with using a central hub so that the devices can independently transmit the data. There are Z waves and Zigbee. These are the technologies which are also now a time it's already a older technology, Zigbee and Z waves, that creates a mesh network between each connected devices. Zigbee can be built in smart devices such as door locks, light thermostats, and more. Right. So if you don't need a large distance network, so you can apply Z waves and Zigbee. Right. It's a smaller like Bluetooth. Bluetooth work in a very small distances area. Right. So if you want to make a systems in smart homes and all, which covers a very small area, right, small distances area, so you can apply Z-Wave and Zigbee. After connecting smart devices to the network, a controller can be used to control the device, right? So a controller, as we have already discussed, that there will be a controller and processor-based devices, which is controlling all the things. The simplest type of control in a smartphone app is such Apple Home app, right? It is controlling all the things. It could be an app, right? It is connected with some device, and device is actually controlling. No, device is controlling all of the appliances, and that is connected from any app. So Apple Home and Amazon Home means Alexa Home is also there, right? So that is a kind of a kit to let control smart homes devices all in one place. It allows people to adjust smart thermostat, turn lights on and off, control locks, and more in multiple rooms. Devices can also be controlled remotely through this app. Right? So these are the smart homes we can already Some of the people here sitting here has also the smart home at their places, right? So they are already using it. If not using, you can just try it. It's a very good and a convenient way to use, and it saves lots of things, our time also itself. Although smart home has brought many benefits to the people lives, the lack of technical standards and heterogeneous platform, a few companies accepted industry standard, which leads to having multiple incompatible platforms and technologies. So most smart home devices by the manufacturer and vendors are generally not built with strong security controls in, right? Most of the smart home system is not basically so secure, right? So smart devices and sensors collect a data of lots of information about people to learn and predict their behavior. To automate a task, they need to know what, where, and when people do a task. So smart devices know it, which room and when the room, when to turn on the light, or when it has to be off. So therefore, connecting these devices to the wireless network and to the internet makes user vulnerable and malicious attacks, further resulting in security and privacy threats such as identifying theft and data leakage. Right? Extracting data from the IoT devices. So IoT forensic relies on sensors places in various devices such as smart kitchen. So it can be applied in different areas at home or wearable devices like fitness tracker. These sensors collect data that the device that transfer from to the cloud where it is stored, analyzed or otherwise made available to intended recipient, or we can share it also to any recipient. This is where cloud forensics and IoT forensic intersects. The retrieval of data that has been transferred from IoT device to the cloud, right? Since data travels through various networks and multiple sources, there can be considerable differences in the methods used to locating crucial digital evidence. So any computer forensics investigation must include provision for multiple standards and data format. IoT security challenges. So already we have done it. So we have lots of security problems in IoT. Obviously, we have discussed it about, right. What kind of security challenges we do have? So we have a security challenge about the distributed public networks. Increase the need of security alarms to protect interconnected IoT device from the intrusions such as data modifications, malicious code injections, sniffing, and denial of systems. Right. So, and many other threats. So, Sonic Wall reported, a company, a Sonic Wall, that reported that the IoT malware attacks increased to 215.7% to 32.7 million in 2018, compared to 10.3 million in 2017. So, to 15% more theft are there, right? The first 2 quarters of 2019 exceed 50% in this first 2 quarters of 2019. If this rate continues, it will be another record year for IoT malware attacks. So it is actually a previous data, but you can see that there is a lots of attacks has been happening, and obviously security systems are also generating, but as a security system has been increased, there is also a, you know, uh, uh, a theft or threats are there, right? So these 2 quarters of 2019 will be exceeded by 55%. Right? The limitation of the IoT devices and networks prevent a straightforward adoption and implementing of IoT sources solutions in the new arising set of security scenarios. Okay, let's come to the point. And lots of resources in IoT devices such as smartphones, tablets, PC, routers, active sensors, passive RFID tags have very limited resources and capabilities to support the implementation and adaptation of traditional security protocol solutions. Hence, the implementation and adoption of traditionally security protocol solution still remain a challenge, making it difficult to provide confidential confidentials of your data transmissions. Right. So it is a challenge to make your data confidential if you are applying these RFID tags or not. So since unattended IoT devices are not supervised because they are operate in self-support manner with limited maintenance, right? So there further leads to concern in terms of data integrity or trust. As a result, the data obtained from the IoT device is likely to be low quality or corrupted. So somehow, if we find data from that systems also, we find that kind of data which is of low quality and corrupted, right? At some point. So the decryption of the data could be happen, but sometimes it will be corrupted and will not find the actual data that we want to find. There are various security challenges like privacy, right? There is some authentication challenges we have. There are some heterogeneity challenges we do have. Obviously, we have. There are some policies are there, right? So policies, what is policy? We have not been uh, uh, done through. So current policies that are implemented in current computer and network securities may not be applicable for the IoTs, right? So some of the computer and network security protocols or policies for IoT due to heterogeneous and dynamic nature. Hence, there must be policies and standard developed to ensure that the data will be managed, protected, and transmitted in an efficient way. This includes a mechanism to enforce such policies is needed to ensure that every entity in applying the standards. Similarly, for every IoT services involved a service legal agreement, right? We have studied about agreement that we should, when we are applying this thing, we should have some kind of agreement so that our data privacy or data security will be there in this agreement, and there is some legal terms will be there also, right? And much clearly identified to introduce trust by human users in the IoT environment, which will further result in its growth and scalability. Right. Digital forensic investigations. Now come to the digital forensic investigations. So we have already discussed something about that. We have something which can be digitally taken data from different digital devices. An IoT forensic investigation where we are collecting data from the IoT devices. Right. So from the legal perspective, if you go for it, so then in the original form of any digital evidences, collecting, examining, analyzing, and presenting the evidence to the court of law. In recent year, with the rapid increase in the use of IoT technology, the forensic investigators are facing new challenges where the traditional digital forensic is inapplicable for conducting forensic investigation, and more research has to be carried out in order to develop frameworks, okay, and guideline for practitioners in such a volatile environment. So the traditional digital forensics mainly deals with evidences such as computers, right? For the mobile devices, from the sensors and gateways, where the evidences sourced from the IoT forensics include home appliances, actuators, sensor nodes, medical devices, and a multitude of other smart devices. Right? For a legal perspective, jurisdictions and ownership issues are essential, similar, but then from a technical perspective, right? So ownership is also an issue. If somebody is the owner of any home or any particular place where a crime happened, so there is a jurisdiction and ownership issues will be there because every area has own jurisdictions. Every country has their own jurisdictions. Every places has their own ownership, and what they feel about that, that is actually matters to us for investigating. So there are many areas that requires further research and development. The obvious example is the lack of forensic tools capable of supporting various IoT devices. So we have we have devices to collecting the data from the digital devices, but we have some lacking devices to collecting data from the IoT devices in the market due to wide range of designs, unclarity of the network's boundaries, or uncertainty of the locations of stored data. Right. So we have not channeled this yet. We have not been, in the standard way. So we need to make this in a standard format that whatever we are doing, it should have all the protocols done, right? And it has a regulatory system to making its updations and all. Traditional forensics investigations, right? So what are the traditional forensic investigations? So traditional forensic investigation is relatively mature field having formal standardization of key processes to carry out investigations. Right? The data acquisition in traditional forensics deals with sources such as hard drives. Right? If forensic investigation is gone through with a traditional way, so what they do for the data, they go for the hard drives. If there is any digital forensic investigation is there, so they need some hard drives, RAM, right, system logs, or any peripheral storage. Right. And for deeper investigation, the examiner can use the technique such as file carving in unlocated space. So the traditional forensics also include the detection of malicious network activities where the network traffics are collected and examining. In addition, currently more crimes, including mobile phone investigation, which has its own challenges, such as we have now, we are facing that kind of challenges that uh, some some of the people will send you some kind of message or link. You just click on that, and your account has been swiped out, right? So that is basically a cyber crime, which is so easy to be done for the people who are doing it, right? They don't need your any sensitive informations of your account, your OTP, your CSV, sorry, the CVV. So there are no information required for that. They are just sending the link, and you just click on that, your account is done. Right. So there are lots of technique is generated with it. So as the techniques is generated, so we also find out the solution that how we can prevent from this problems. Right. So after the data acquisition, and this is because of data only, because we are spreading our data in in a daily basis, and each and every websites, in each and every application we are sending our data, we're sending our location, we are applying some kind of informations in different websites, so they can collect the data from anywhere. They have all the informations of you, right? So that we should prevent by ourselves, that where we should go for to prevent our data or not, that whichever application, whichever websites we are using is actually have the security system or not. First we'll have to check it, right? They have policies or not, because some of the companies, they are taking your data without any policies. If you claim for that, they'll also give you some counter back that there is no policies of getting your data back or getting your things, right? So if you are giving your data somewhere, or any banking information or any sensitive information, they should have any policies for that, right? So in simple word, it can be said that the traditional forensics in sub area of forensics investigation in IoT, because of latter consist of examining more varieties of digital devices. Right. We will have multiple devices to collect the data. We didn't have only the hard drive and files and RAMs, right, and the peripherals. We will have multiple kind of devices where we can collect our data in the form of which is generated from different IoT devices. So, in the investigation of IoT, because of latter consists of examining more variety of digital devices which are intercommunicating and data syncing among each other, as well as the cloud server. One of the major complexity in the situation is maintaining the chain and custody and legal requirements. Forensic investigation in IoT and smart home, right? We are considering only the smart homes. So what are the problems? How do we investigate any IoT system which is placed in a smart home? So proliferation of IoT devices and the increase in number of cybersecurity crimes have given rise in enhanced forensic investigation technique in IoT. The smart home can be counted as a simple form of IoT environment, which can be a good research starting point to explore the challenges of conducting forensic investigation in IoT environment. So that is a very easy way, and a smart home can be easily generated, right? So there are already lots of appliances has been made for the smart homes. So if you want to make any kind of researches on that, on any IoT forensics, you can use it with the you can apply it with the smart homes also. That is a very easy way to do it. Some of the main challenges that the forensic examiners have to overcome in any forensic investigation exist in data acquisition stage and the data analysis stage, where the proper and suitable forensic tools play an important role. Right? There is a forensic tools which data acquisition will be there, the data gathering will be there, and data analysis will be there, which plays an important role in supporting the forensic examiners in the investigation. Right. In terms of identifying the sources of evidences in smart homes, the IoT devices, the home and hub gateway, the mobile devices on which the IoT application are installed, and the cloud servers to be main sources of evidences in any type of smart home investigation. However, it is important to consider situations where some of these IoT devices may not present in the crime scene at the time of seizure, such as wearable or mobile phones. Right. So that could be a solution, that if there is a mobile and somehow any mishappening is there, but the phones are not there, some of the wearable devices are not there, data could not be collected into it. Right. The data from these sources can be extracted from the local storage of IoT devices, the user application, data storage, or the mobile devices. The incoming and outgoing network traffic via the home and hub gateway, and the cloud servers that are holding the user's data on the personal accounts. Right. So in IoT forensics, there are three ways of doing this. First is traditional forensic, second is network forensic, and third is cloud forensic. Traditional forensic is same as we are already doing with the digital forensics. That is a traditional forensics, right? Second is network forensics, where we are analyzing our data from the networks, right, which is stored in the networks, which path it has gone, from which path the data is coming, from which path the data is going. So where it breached out, from where the request from. So lots of things are there in the network forensics, and one is cloud forensics, to finding out the cloud data where it has been shared and from where the data has been requested for data requesting, right? So from the server location, from the cloud locations, from the network location, we can search it out for the investigation process, right? The traditional forensic investigation zone includes the forensic analysis for the local storage of IoT devices and any other digital devices connected to the smart home, such as computers, mobile phones, right? Whereas the network forensic investigation zones covers the forensic analysis of the network, right? First, the traditional forensic investigator zone has a different zone, right? As we have already studied, that there is a different zone which is analyzing the local storage of your IoT devices and any other digital devices connect to the smart home. Second is network forensics. Network forensics investigations zone covers the forensic analysis in the network traffic, right, of the IoT devices, the smart hub gateway, and the home routers, right? And these first two zones may not require much cooperation from the any third parties. But the third one is cloud services. The cloud services, you may always take some cloud services from the third party, right? You cannot install it by own way. So you must have dependent upon those companies which are providing you the cloud services. So cloud services provider, but the forensic investigation of cloud servers will definitely necessity of the collaboration with the cloud service provider, which overcoming the jurisdiction challenges from legal perspective, right? So this is also a challenge because who is the provider of the cloud, right, has a kind, they doesn't have any policies to give you the data. They have a policies in between user to that company, but they don't have any policies to give that data to the public bodies or public, elements like police and all, right? Police and court, they don't have any legal agreement. That is also maybe a challenge. Challenges in IoT forensics. Let's study about the challenges. The first challenge in the IoT forensic is some data is heavily encrypted. In some cases, descriptions or decryptions may be highly problematic. For example, if the decryption token has been lost or corrupted, or if the encryption method is unusual or error prone, often data suffers from corruptions during transfer, or as a vendor store it over extended periods, right? Second, thankfully, many companies have policies to preserving their data, not preventing, it's preserving their data throughout a specific period, right? However, providers also typically protect data from the access, except when someone can prove a legal rights to access the data. This means that data forensics may require legal actions and may special permission that can be difficult to obtain depending on the individual policies. Challenges and techniques. The diversity of IoT environment is the challenges, right? It is also technique also, but it may produce some challenges for the investigators who are investigating the data for finding some evidences. Right, the IoT environment is comprised of devices ranging from low and sensor to the smart devices, each serving their own purposes. The computing power, battery life, heterogeneity of operation system, use of a network protocols, and storage capacity in each of these devices varies from device to device. Performing forensic investigation on such devices can be challenging as the technology is constantly changing and updating. Therefore, existing tools and softwares are not adequate to exact data or evidences from wide variety of devices. Second is complexity of IoT architectures, right? So the IoT architecture systems are presented can be complex due to the heterogeneous operating systems, right? Every time we are using a different operating systems and hardware used in devices. Gateways is different, edge devices could be different, and the data centers is different. IoT devices manufactured use a variety of proprietary hardwares and softwares to develop new devices with the advanced technologies and functionalities. Right. So this requires the use of different standards and protocols as well as. So this is the complexity of IoT architecture, which is to be also taken as a. It's obviously a technique because of we are exploring our IoTs, right? But the problem that could be difficult when we are using different protocols in different devices, right? So this IoT architecture complexity can also provide some problems when investigation in forensics. So diversity of IoT environment and complexity of IoT architecture, these are the challenges. Third is the challenge, big data, big IoT data. So big IoT data is large volume of data that is generated and stored by the multiple sensors using an IoT device, right? So it may have multiple datas, right? There are lots of data. It's called big data, and big data is managed with the softwares, but in the form of investigation, it could be a challenge to finding out in a very lesser time. Because if something evidence has to be collected, there is a timeline also, right? That in this timeline, you'll have to find out the evidences, right? So if data is would be larger, that will take lots of time, right? So big data is also a big challenge for the IoT forensics. Next is multiple or multi jurisdictions. So due to distributed nature of IoT data storage arising from use of cloud storage and edge servers, forensic investigators are faced with the legal issues arising from the multiple jurisdictions. Right. Let's say I have some problems with my data. Somebody thefts my data, right, and steal my data, and I want to make an IoT forensics where this data is uh, basically been taken, which sources I have to find the source where it has been taken. So what I'll do, the problem is I have my own device, I have my own security points, I do have my own jurisdiction system in India, but where it is been kept in the cloud is in the US or UK, they have their own jurisdiction system. So for this, we'll have to follow all the jurisdictions for making this possible. Right. So jurisdiction systems and their laws can have different, right? So every areas or every countries, even in a single countries, we have multiple states. Multiple states, we have multiple districts, and they have their own jurisdictions. Would have, right? So if there are different rules and regulations are there, that will be a problems for taking into account as that we can easily access all of these things. No, we cannot do, right? So the victim device, the attackers, and the stored IoT data may reach each be at different global locations, making it difficult for the forensic investor to decide under which law to prosecute the case. Right. So this is the problem. Next is privacy concern. Privacy concern is, of course, we have some private data from the IoTs also, from the IoT devices also. So it's a privacy concerns also, right? So it is a big challenge. Next is to chain of custody and data integrity. For acquiring evidences to be accepted as a legitimate and admissible in court of law, and it is mandatory to prove the chain of custody and data integrity. This became challenging in IoT forensics as data are moved from devices to the cloud due to inherent storage limitations. The court required the chronological history of evidences and proof, that is, they need to follow the chronology, right? So where it has happened, from it is connected to another things, it is connected to another thing. So the chain which has been followed from for that crime is to be taken, right? And court has always works on that chronology which happened in that process, right? So that if we are taking into it, and if one of the chronological thing is missing, if we do not find them, we cannot apply that into the code, right? That what happened, what would happen, right? So that is basically in the form of a chronological system that we need to follow, where it generated, how it is generated, why it is generated, right? So anything which is missing in the chronology cannot join them, cannot bridge them, right? So that is also a challenge. Security is also a challenge, right? Most IoT devices are basic sensors that are vulnerable and external attacks. IoT devices are deeply integrated into day-to-day operations, right? Evidences found through IoT forensics. So collecting evidences on the device level has many limitations. The survival period of data is limited in IoT devices as they usually have limited storage capacity. This can lead to important data being overwritten, making it impossible to trace the attacker activities. There is also the problem of limited visibility of data as it must be extracted from the device firmware or flash memory using special tools, right? So there are lots of ways and challenges or techniques that is actually performing by the attackers, right? And we'll have to prevent by some technologies so that it would be resolved. These are the challenges. We are not getting it yet, but in the recent years, we are working on it actually. So some of the researchers are doing it, and some of the challenges in acquisitions also, that vendor designs, specific vendor design, proprietary interfaces, right? Non-negotiable reverse engineering attempt. Okay. Locating data traces. So maintaining data quality in evidence is essential for IoT forensics. So extracting data involves working around the challenges of following a digital footprint throughout the various data collection and storage stages. IoT forensic expert has developed various automated methods to simplify the investigations process and make it more efficient, resulting in clean, parsed, and structured data that can be used for the investigating purposes. Right? So in data devices, traces in devices, data traces in network, data traces in cloud, that we have already performed that. Yes, this is the way we can trace our data from the network, we can trace our data from the low level devices, and we can trace our data from the cloud itself. Okay, and the application of forensics, what we can do with the IoT forensics. So first, digital evidence collection, obviously. We have different ways of digital evidences, finding techniques, right? From the smartphones, wearables, house automation system, and all. Second is digital forensics, is devices or a technique from different geolocations data or timestamps, right? Third is reconstruction of crime scenes, right? By forensics or some kind of forensics, IoT forensics, we can reconstruct the IoT, we can reconstruct the crime scenes. And IoT devices can also be used to reconstruct crime scenes by providing data on the movement of people and objects. For example, data from the smart home devices such as security cameras or smart doors lock can be used to track the movement of people within a building. So we can make a reconstruction of the same uh, processes, right, with the help of IoT and the data we have stored, which we have collected from different IoT devices. Right. So security cameras would be there. So security, we can find out the which security cameras and what is the timestamp it happens. Right. Second, which when the lock has been broken, when are the different devices is been used. So there are lots of data can be collected from there, and we can reconstruct the crime scenes again, and we can find the pattern from it. Third is reconstruction of crime scenes. IoT device can also be used to reconstruct crime scenes by providing data. Okay, this is done. Okay, cyber security. Cyber security IoT devices may also be used to investigate cybercrime by providing evidences of hacking attempts, data breaches, or other forms of digital intrusions. Right? Predictive analytics. IoT devices can be used to gather data that can be analyzed to identify pattern or trends that may be relevant to a forensic investigation. So sometimes it will be a predictive analysis also. Now, sometimes it could be happen that crimes doesn't take place, but we have some kind of sense that it could be take place over there, right? Because of the pattern we have followed and the thing we have seen, right? So by predictive analysis for artificial intelligence, by machine learning also, we can predict some kind of you know uh, before crime predictions, that it could be happen, like some attacks could be prevented before it happens, right? Because of predictive analysis. So, and we can use it in the forensics ways, right? And we can apply some mathematical algorithm so that it can make a prediction that yes, this crime could be happen at that place at that time. So you just have to, worry about this, and you just need to prevent this, right? Overview of current IoT forensic frameworks. Okay, let's come to the framework. Before coming to the framework, please take a 5 minute break, then we'll start it. The IoT frameworks, which is already researched, and how it is researched, what is kind of things which is used in this framework. So we'll be taking 5 minutes break and then we'll start. Okay. So you don't have to, disconnect it. I'm over here. I'm just mute my mic, and in 5 minutes we'll be connecting.
Hello, hello. Hello.
Okay, let's start again. So we have already discussed about the forensics, right? IoT forensics, where it is applied, where we can apply, and what kind of challenges we are facing for applying IoT forensics, right? So next, we'll be discussing about uh, forensic frameworks. So some of the frameworks has been designed, right? Most of the people have reserved that kind of frameworks that how it could be implemented, right? So in advances in digital system, together we are rapidly growth with the IoT era have a caused crucial period in digital forensics. So some of Mauro is a scientist. He was identified that there is no documented method or reliable forensic tools to collect forensics sound artifact from a device. Means there is no any kind of documented method for that. So the diversity of IoT environments has made it difficult for forensic investigator to acquire and analyze data using traditional methods. So the IoT devices are known to have customized operating systems or file structures. The number of wireless protocols, the lack of appropriate tools and methods in difficult to identify and acquire data from the IoT devices. So in recent years, these have attempts by various researchers to develop IoT frameworks, to facilitate digital forensics investigations in IoT environment, as well as the ensure that evidences is acquired in a forensic manner. Right. An overview of some of the known IoT frameworks that were proposed in last few years. This table outlines the main stages of these frameworks. Let's check it. Okay. So first of all, Oriva. Oriva proposed a systematic approach to identify sources of evidences within the IoT environment using three zones. Right. So Oriva has proposed a kind of a framework which is made with three zones. First zone emphasize on the internal networks such as hardware, softwares, and network connections. Second zone focuses the peripheral device such as IDS, IPS, firewalls, and gateways. And third zone focus on the hardware and software outside the network, such as cloud and internet service. Further, they also presented a forensic edge management system to provide an autonomous forensic services within a smartphone. Right. So this has been presented, and this is actually a very foolproof idea that we can do it very well. Second, in 2015, Parimal proposed an integrated model, designed based on tri-edge model and 1, 2, 3 zone model for the volatile system data preservation. The proposed IoT digital forensic model includes the following procedure: authentication, planning, chain of custody, and analyzing and storing them. Right. So, however, it is not address the digital forensic readiness process, and the research work was presented in a shallow manner. Right. So this is also the same way that this Oriva has presented, right, for, in three zones, but it has something different for the process or the authentications, planning also, and the chaining of different systems, analysis and storage. Next, Zavoda process a centralized trusted evidence repository in the forensic aware IoT, FAIoT, forensics aware of IoT conceptual model, which is aimed at giving supports in executing digital forensic investigation in the IoT environment by providing an analysis of existing challenges. So their proposed approach is constantly monitored, registered IoT devices and provide access to evidence through the use of API services to law enforcement authorities. So they made an APIs to collect all the data. So there is no any regulatory different regulatory system. There is one regulatory system which are regulating those all things in a single API. So it will be very easy to finding out data from any applications, right? So this could be happen, and this is basically not a foolproof ideas, because the paper served as introduction of IoT forensics domain and high-level investigation. It is a partial artifact acquisition. It is not done yet. Kibande and Ray proposed a framework that compiles with ISO, Standardization Organization, 2015, which is an international standard for information technologies, security techniques, incident investigation principle and processes. However, the proposed framework is generic and the effectiveness of framework was not tested. Right? It was not practically tested, but yes, this is the given proposals that we can do this with the help of standardizations. In 2018, the authors proposed an IoT framework. This framework was an extension of initially proposed generic digital forensic investigation framework for IoT environment. IDFIF is an IoT framework. This framework was an extension of initially proposed generic digital forensic investigation like this, right? Framework for IoT environment, which was addresses the lack of IoT digital forensic investigation standardization. So it has put some standardization into it. This enables the analysis of potential digital evidences generated by the IoT ecosystem. However, the framework lacked ground details that IoT forensics and overview of current issues and challenges. 245 would facilitate simple similar adaptation to different scenarios without changing any main components and processes. Right. So these were given proposed in 2018, where the same proposal which were made in the generic way, right? Like in Oriva proposed the system, zone 1, zone 2, and zone 3, the same generic proposal has been given, but with the standardization techniques, right? Where some standardization has been given to devices, standardization has been given to the networks, and standardization has been given to the clouds, right? And because of this standardization, they made some policies, and because of those policies, they can easily handle or manage their data, right? And that can be investigated in the form of the uh, in the regulatory system and also in the jurisdiction system, right? Within. Next, method proposed the FSA IOT framework, which comprises a centralized forensic state acquisition controller employed with three collection mode known as IoT device controller. Okay, so here what they have done a connections for that. Right, there is no zone over there. They have made different connections for that. First connection is called device controller. Second connection is called cloud controller, and third is controller to controller, means which can control the controller. Right. So with this forensic state acquisition controller, there are three types of controllers are there, where there are regulatory controller which regulates the IoT devices controlling. Second, a cloud controller which controls the data of a cloud, and third is the controller of controller, the single controller which is controlling the devices